9.7, Law of Sines and Law of Cosines. Essential question, can I use a new area formula for triangles that uses trigonometry? Can I use a law of sines? Let's take a look at a triangle and talk about how we label it. The vertices of a triangle is labeled capital A, capital B, capital C. The sides will be labeled lowercase. So side A will be opposite angle A. Side B, which is displayed as lowercase b, is opposite angle B. And side C, which is again labeled lowercase c, is opposite angle C. And we'd like to prove this formula works. To find the area, notice it has a trig relationship in it. Okay, we're going to do this by drawing an altitude to this triangle. And remember that this whole side is B. So let's go ahead and write our traditional formula for the area. It's 1/2 the base, and the base happens to be B, times the height, which is H. And now we'd like to find a formula to write an equation for the sine of C. So here is C, and remember when we talk about sine, we talk about a right triangle. So we're talking about this triangle right here. And we know that the sine of C is equal to the opposite, which is H, over the hypotenuse, which is A. And we know that we can cross multiply, and H will be equal to A sine of C. So now let's go back to our triangle formula here, and we're going to say area is equal to 1/2, and again the base is side B, and the height can now be replaced with this, which is A sine of C. And that's what I'm getting right here. So here's a new way to describe the area of a triangle. Now let's go back to what it looked like before. Remember, this is what it looked like. It was A, B, C, and this was A, and this was B. And so this formula really says in words, it says take 1/2 a side times another side times the sine of the included angle. And that's what our next theorem is going to say. So the area of any triangle is going to be 1/2 two sides, so we're going to use B and C, two sides B and C, times the sine of the included angle. The sine of the included angle. So if you work with another two sides, like A and C, your included angle will be B, and if you work with A and B, your included angle will be C. All right, so here's a triangle here, and I can see my angle, and I can see my two sides. So the area will be 1/2 times the two sides, which is 19 and 17, times the sine of the included angle, which is 135. Let's just go ahead and put this in our calculator and round to the nearest 10. And our answer is 114.2. Okay, your turn. Before we start though, let me get you started on this first one, number 4. Let's go ahead and write our vertices here. So we're going to write A, B, C. Our B is 60 degrees. Remember that this is lowercase b, this is lowercase a, which happens to be 19, and this is over here lowercase c, which happens to be 14. So here we have our two sides, and we have our included angle. So our answer, area, will be equal to 1/2 14 times 19 times the sine of 60 degrees. And when we put it in our calculator, that'll be 1/2 times 14 times 19 times the sine of 60 degrees, and that's going to be about 115.2. Take a minute to stop the screencast and see if you can do the next one on your own. And here is the answer. Okay, let's take a look at using this formula to help us derive the law of sines. So here's our picture again, and we have all of these areas that work depending on which angle we use. So these are all areas of the same triangle. And so what I'm going to do is I'm going to set them all equal to each other. Okay, and then what I'm going to do is I'm going to multiply everything by 2, and that'll get rid of the 1/2. And then I will divide everything through by ABC. So the B's are going to cancel, the C's going to cancel, and I'm going to have sine of A all over side A. And the C's are going to cancel, the A's are going to cancel, and I'm going to have sine of B over side B. And I'm going to have the A's cancel and the B's. Oop, not. This should have been a C. The B's are going to cancel, and this will be sine of C over side C. And that is the law of sines. Now, it can look like this, where you have the sine in the numerator, or you could have it where the sine is in the denominator. Both of these are called law of sines. All right, before I go to any further, I need to tell you that the law of sines is used when you have two sides in a non-included angle, two angles in a non-included side, or two angles and an included side. Those are all appropriate for law of sines. In this case, I have two sides and a non-included angle. Two sides and a non-included angle. So this is appropriate for the law of sines. I'm going to write out the formula, sine of A over side A, sine of angle B over side B, side of angle C over side C. And I have the sine of 115 all over 20 equals sine of angle B over 11 and sine of C all over little c. Okay, so I'm looking right here, and I'm going to cross multiply 11 times the sine of 115 is equal to 20 sine of B. So sine of B is equal to 11 times the sine of 115 over 20. And then to get the measure of angle B, I'm going to take sine inverse of this quantity, 11, sine of 115 over 20. I like to do this and let the calculator do all the work instead of me doing all the work. So I press sine inverse in my calculator, and then 11 times sine of 115 divided by 20. Don't forget your parentheses, that's going to be important. And so the measure of angle B is approximately 29.9 degrees. So angle B is 29.9 degrees. Now I'm going to subtract from 180 those two angles that I am looking at. And when I do that, this angle C is going to be 35.1. So now this angle C is 35.1. So 35.1. And now I'm going to use these two to help me find C. So I'm going to write sine of 115 over 20 is equal to the sine of 35.1 over C. I'm going to cross multiply. And so this is going to be C times the sine of 115 equals 20 times the sine of 35.1. And then C is 20 times the sine of 35.1 all over the sine of 115. The calculator can take this. So don't go to your calculator until you get to a point that you have everything to one side. And when I put that quantity in the calculator, I get C to be approximately 12.7. So I found all my angles and all my sides of my triangle. Okay, now you can see number 6 is a side-side angle, and number 7 is a side-side angle. See what you can do. Stop the screencast. And here's the answer. So you can see that I went ahead and set up everything, substituted those values, and got all my answers. Okay, here's another problem. It's an angle side problem. I'm going to do much the same thing as I did before, but instead of writing out the formula, I'm just going to write out, I'm going to just start out sine of A all over little a. Now I do know B, so I'll just, instead of B, I'll write the 25 over 15, and then sine of C, and I know C is 107 all over little c like this. Okay, so with these two, I think I'm going to solve this one right here because I'm just looking for a C. So I'm going to cross multiply. 15 times the sine of 107 is equals to the sine of 25 times C. So C is equal to 15 sine of 107 all over sine of 25. I'm going to put that in my calculator. And you notice I don't go to my calculator until everything's on one side. Let the calculator do the work. And so this is 33.9. All right, now to find A, I'm going to actually find angle A. So I'm going to take 180, take away 25, take away 107, and I have 48 degrees, which over here is 48 degrees. And I can go ahead and cross multiply and then divide by that. So A will be equal to 15 times the sine of 48, and then I divide by sine of 25. And I go ahead and put this on my calculator. And I get approximately 26.4. So I found all the sides and all my angles for this triangle. Okay, your turn. Go ahead and stop the screencast and see what you can do. And you can see one is an angle side and the other is an angle side angle. And this is the end of the screencast.